Hello everyone, myself Deepa. Today I'm going to explain about the critical section problem. So coming to the introduction. So in introduction we have three major problems or the topics that we are going to deal. That is what is critical section problem and why is the critical section problem important and solution to the critical section problem. So these are the topics that we are going to look into in the critical section problem. So in critical section problem, we are just going to learn what is a critical section problem and why is it important and solution regarding the critical section problem. So coming to the what is critical section problem. So the critical section problem can lead to a race condition, deadlocks and other synchronization issues that can cause programs to behave unpredictably or even crash. As such, it is essential to understand the problem and its solution to write reliable and efficient concurrent programs. So, a critical section problem can lead to a race condition such as deadlocks. We know deadlocks where we have some interference between the programs. So the deadlock conditions and other synchronization issues that can cause a critical section problem. So in that case, the programs behave unpredictably or even crash. So the critical in when we have a critical section issues or the problems, so the programs can even crash or it can go unpredictably. So that is a critical section problem. As such, it is essential to understand the problem and its solution to write reliable and efficient concurrent programs. So therefore, it is necessary to understand what is a critical section problem and the solution, which is reliable and efficient concurrent programs. So when we have some crashes in the program, it is necessary for us to understand what is the problem and find out its solution and have a solution in such a way that it's an efficient concurrent program. So coming to the next slide, we have critical section problem. The critical section problem is a fundamental issue in concurrent programming that can have serious consequences if not addressed properly. So it is a fundamental issues in which that can lead to serious consequences if not it is addressed properly. When multiple threads or process access a shared resource such as file or database, there is a risk of data corruption or inconsistency if they are not synchronized correctly. So when the multiple threads or processes access a shared resources such as file, it can be a file or a database, there is a risk of data corruption. The data can go corrupted and inconsistency if it is not synchronized correctly. For example, you can take an example such as imagine a banking application that allows customer to withdraw money from their account simultaneously. If two customers try to withdraw money at the same time, there's a risk that their requests will overlap and result in an incorrect account balance. This could lead to financial losses for the bank and erode customer trust. Therefore, it is crucial to implement proper synchronization mechanism to prevent these kinds of issues. So, it is a when multiple threads go hand in hand, such as file, it can be file or a database, there is a risk of data corruption. So it needs to be corrected by synchronizing it in a right way. So that is what is a critical section problem. Let's move to the next slide, that is critical section problem. So we in systems how it goes on or how it does. So when you consider a system consisting of processes from p0 p1 to pn minus 1, so you have so many processes that go hand in hand. Each process has a segment of code. So the process has each segment of code called as critical section in which the process run. So when it consists of an system, the process can takes place from P0 to P1 to P2, P3, Pn to Pn minus 1. So each process has a segment of code called as critical section in which the process may be changing common variables, updating a table, writing a file and so on. So in this critical section, it can be changing a common variable, it can be or updating a table or writing a file and any other things can also be done. The important feature of the system is that when one person is executing in its critical section, when one process is executing in its critical section, no other process is to be allowed to execute in its critical section. So when a process is already executing in the critical section, no other process are allowed to execute in its critical section. So only one processes can happen one time. and the other processes has to wait for the next one to execute. So it cannot go hand in hand or simultaneously. Two processes cannot happen in a critical section. That is what it means. That is, no two processes are executing in that critical section at the same time. The critical section problem is to design a protocol that the processes can use to cooperate. So a critical section problem is to design a protocol that is to execute. So in general, structure of a typical process PI is shown below. In a critical section, each process must request permission to enter its critical section. So a process should, if a process should enter into a section of code, it has to request a permission. So the section of code implementing this request in this entry section, it is called as an entry section. The process must request permission to enter its critical section. After its permission is requested or accepted, the section of code implementing this request in the entry section, so that is called as an entry section. The critical section may be followed by an exit section also. The remaining code is the reminder section. So we have three types of sections. We have an entry section, a critical section, and an exit section, and also a remainder section. So when you have a code, we take a do and while loop, and when a program or a process starts, we have an entry section where the problem is executed in that section, and the critical section will be a place where the problem is or the processes can occur. And you have an exit section and also a remainder section, and while a true. So when you have such a problem and there are two processes running on and you should not have any clashes between the two processes, we have something called as a solution for this critical section problem. So every processes must execute. So we have three solutions. So the solutions are mutual exclusion, progress, and the other one can be seen in the next slide. So coming to the first solution, you can see in a critical section problem, there is a mutual exclusion. If a process PI is executing in its critical section, then no other process can be executing in their critical section. So if there is a one process that is executing in its critical section, then no other process should be executed in the critical section. As we have seen in the above slides also, it means that the critical section problem, when you have a critical section, only one process can take place and the other process should wait for the next execution. Until then, only one process can be executed. So the progress is another solution for the critical section problem. If no process is executing in its critical section, when there is no process which is executing in a critical section, and some processes wish to enter the critical section, then only those processes that are not executing in the remainder section can participate in deciding which will enter its critical section next, and this selection cannot be postponed indefinitely. So let's read it again. If no process is executing in its critical section and some process wish to enter their critical section, if there is no process that is executing in the critical section and there is another process that wish to enter the critical section, then only those processes that are executing in the remainder section can participate. So when there's a process executing already in the critical section and there's another process which is requesting the critical section for entry, the processes that are not executing in the remainder section can participate in deciding which will enter its critical section next, and this selection cannot be postponed indefinitely. So the third solution is the bound waiting. In bound waiting, there exists a bound or a limit on the number of times that other processes are allowed to enter their critical sections after a process which has made a request to enter its critical section and therefore that request is granted. So in bound waiting, there exists a bound, or you can call it as a limit, on the number of times that other processes are allowed to enter their critical section. After the process has made a request to enter its critical section and before that the request is granted. So other processes are allowed to enter the critical section only after the process has made a request to enter its critical section and before that request is only granted. So that is where the solutions of critical section problem. So there are three solutions in the critical section problem, and these are the solutions. So thank you and thanks a lot.